Okay, so really the first functional groups that we had were the alkenes and alkynes. Okay, and why they're functional groups is because anytime that you remove like a hydrogen, say we have this sort of thing, if we take off one of these hydrogens and we use those electrons to form something else, it's basically changing the function of the compound, right? So if we just remove this and remove this and use those electrons to form a double bond, well, that becomes an alkene, right? Okay, and if we remove this and this and form an alkyne, okay, so we functionally have changed what this is. Does that make sense? So that's kind of a review. That's what we did earlier. We had alkanes, alkenes, and alkynes. So then also we can put smaller alkanes on larger ones. Again, this is a review. So when we do this, it would be something, and I'm drawing all these out because I think it kind of helps. If we had all these like this, and we just replace like this hydrogen here with a methane. Let me draw it in a different color. Maybe that'll help. Like that. That functionally changes what this thing is. So this becomes an alkyl that's on an alkane. And usually when we draw this with a skeletal structure, it would look like that. Okay, so that kind of catches us up to speed on the various alkenes, alkynes, and alkyls. Do you guys have questions on that? Any? Okay, so now we moved on and we talked about alcohols and haloalkanes the other day, but I just want to hit them real quick. So with the alcohols, we're adding what's called a hydroxyl group, and that's just hydrogen and oxygen. If you look at hydroxyl, it's oxygen and hydrogen. That's why it's called a hydroxyl group, and it's an OH. Okay, so again, all we're doing is just replacing a hydrogen like let's just replace, you can't really see it that well with the glare here. Let's move this. I'll just take away the glare. It'll come back for us. There it is. And the way that you name alcohols is you just name the alkane. So in this case, it'd be ethane, and you just end it in all. Okay, so this was the stupid joke when I had you guys make, ethanol, and I said, shame on you guys. I don't know if it was this class or not. I said, but you're holding vodka, you're holding beer, you're holding wine. Okay, so this is grain alcohol, this is wine, this is whatever, this is ethanol. Okay, ethyl alcohol, it's what's in this bottle right here. Okay, and all we did was just replace one hydrogen with a hydroxyl group. That forms an alcohol. Okay, and if there's multiple carbons, we'd need to put like what carbon the all is on. Okay, so if we did something like this, and we were making 1, 2, 3, 4 butanol. We'd need to say that's on like the first, because that'd be the first one. Okay. Okay. All right. So then we talked about the halogens are the haloalkanes. And all we're doing here is we're just taking fluorine, chlorine, bromine, and iodine, and we're replacing a hydrogen with one of those. So it takes something that's pretty stable, okay, like propane, and makes it become pretty reactive. So let's say we replaced that one with an I. So what we would have here, if we draw it out skeletal-wise, is maybe something that looks like that. Now remember, the line, if it's just a line, has a carbon on it. But if there's a letter attached to the line, then there's no carbon. So there's not a carbon, if you guys can see this, right here. There's a carbon here. I usually like to try to make the line a little bit shorter. That way you know it's just a bond. Okay? So what we would have here is propane. And on the first, we have iodo. So it would be iodopropane. All right? And you can do this with multiple, if you have, say we did it, put another iodine here. So now we'd have diodo. Okay? And so forth and so forth. Okay? All right, so that's the halogens. Now, here's something we haven't covered very well. This idea of cycloalkanes. And this is where you get your kits. So have we done this yet? Have I showed you cycloalkanes? Oh, I did? Yeah. With the springs? Where you made like geometric shapes? Okay, that's fine. If we did, we did. I just want to make sure. This week's been a little crazy for me. So anyway, you're going to have to make one of these for your project. So I just want to make sure you understand. So it would be something like this. All right, did I show you that? Oh, okay. So with cycloalkanes, basically what happens is the ends meet. All right, because normally you would have like hydrogens like this, right, all the way around and like a straight chain. Well, what happens is this thing bends on itself. Okay, so cyclos become even more stable, okay, because they're going to reduce the number of hydrogens by 2, and then they're going to bend it on themselves, and this will bond. So it will look like this. So you end up forming something like that. Okay? Does that make sense? Now, some people yesterday were like, well, it's got springs, so it has to have a double bond. No. You just use the springs because it's impossible to bend these things to form with wood, right? It just doesn't work. So the springs don't represent anything other than one bond. If you had 2 of them, which you can do, and you did this cute stuff, like that, well, now you just did what's called a cycloalkene. Okay, so you just put a double bond on this, like that. And in this case, this would be cyclo, and there's 3 of them, so it's propene. So the cyclo part is just saying that it forms like a shape. Like, what would that be? Just a box. Or if you want to draw it like this, that's fine. What are both of those? How many carbons do I have? 4. What's 4? Bute. So it's butane because they're all single. So it's cyclobutane. Is it that hard? Is that big a deal? So then you can also like add stuff to it. Like if you put a CH3 out here or something. So this would be like 1-methyl cyclobutane. And I ran it off the thing. 1-methyl cyclobutane. And you can add the halogens to it. Okay. So if we put one right here, we put an F right here. This would be 1. You're like, well, how do you know it's 1? Well, just if there's one thing, it's a 1. And if there's multiple, use the smallest numbers. 1 fluoro cyclobutane. Okay, so that's the cycloalkanes, alkenes, and alkynes. They just turn on themselves and make a geometric shape. Okay. All right. So now we need to go into a couple of the new ones, which I'm not going to do a whole lot today, but I just want to show them to you. There's one that's really, really similar to an alcohol. They're called aldehydes. Maybe you've heard of stuff called formaldehyde. Ever heard of that? Like embalming fluid? Okay. So aldehydes are pretty simple to recognize because what they have on them is a double bonded O, and it has to be on the end. Okay. If it's got a double bonded O on the end, it's an aldehyde. And they're really simple to name. Okay. They're very similar to the way you name alcohols. Alcohols, you added OL, right? Aldehydes, you add AL. So this would be ethanal. Ethanal. That's all it is. So whenever you see something that's drawn out like this and you see it with like a double bonded O at the end, and it has to be, that's not drawn very well. And let me do it in a different color so that you can see it a little bit better. You see this, that is an aldehyde. So all you do is like what we've been doing, 1, 2, 3, 4, 5. This is pentanal. Not pentanol, pentanal. Got it? So the double bonded O on aldehydes, double bonded oxygen on end. Well, technically it could be down here too, because those are both ends. So, okay. And aldehydes are used in all kinds of stuff. It's actually what makes vanilla, like the flavoring and like the smell. Have you ever heard of citronella? Like the candles that supposedly keep away mosquitoes. I think that's aldehydes are in that too. Essential oils have aldehydes in them. Okay, so yeah, like all kinds of they're used a lot in perfumes. Okay, like almond extract and things like that are aldehydes. Okay, so then the last one I want to talk about today, and I'll let you guys move on, are these things called ketones. And ketones kind of get used, thrown around a lot because of people that go on Atkins diet or like only eat meat. Okay, basically it's like an aldehyde, but the double bond is in the middle now. So it would be something like this. Okay, and you'd have your H's around like that. So the double bonded O is in the middle somewhere. So double bonded oxygen inside carbons. Okay, so if you had 10 carbons, as long as it's on 2 through 9, it's a ketone. Okay, So it might look something like that. That would be a ketone. And they're pretty easy to name too. All you do is just name, like in this case, 1, 2, 3, 4, 5, 6. This is a hexane, right? And then all you do is put 1, hexanone. You just put 1 because it's a ketone. So a lot of these, like aldehydes, it's the Al. Alcohol, it's the Ol. Okay. Alkyls, Yl. Ketones, 1, O-N-E. And then you just say which one it's on. 1, 2, 3. It's on the third one. You always have to, for ketones, you always have to use a number because they're inside. Okay. If it's on the outside, then it's an aldehyde. That's the way you tell the difference. So ketones are like, they're a big part of our body. Okay. They function in what's called anti-inflammatory with like cortisol. So ketones are a big, huge part of our immune system. They're a big part of sex hormones. Very, very important in progesterone, female hormone. They're used everything from the process of making like blue cheese to deers have it in their musk scent. So ketones are found everywhere in nature, okay? And they're also a big part of digestion, okay? Then you can go through a process called ketoacidosis, which is not the greatest thing in the world to happen, especially if you're diabetic. Okay, so that's all I got for today. Okay, all right. So what I want you to do